हे गाइस, वेलकम टू माय यूट्यूब चैनल। इट्स अंकिता चौबे और ये हमारी केबल्ड एंड आर्चेस की थर्ड सीरीज़ है। तो आज हम जानेंगे अगर कंसंट्रेटेड लोड किसी आर्च पे लगता है तो कैसे हम एनालिसिस करेंगे। तो डिटेल एनालिसिस में देखेंगे इसे, मगर इसके पहले जो मेरा लास्ट वीडियो है उसको ज़रूर देखें, पूरे कॉन्सेप्ट उसी में है। सो लेट अस बिगिन।
We wish to analyze it under a concentrated load of 120 kilonewtons placed at its crown. Knowing H and L, we can rewrite Fx like this. Since the arch rests on a pin at either side, we end up with a horizontal force and a vertical force at each end. In this case, the two vertical reactions can be easily determined by using the equilibrium equations. To determine the horizontal reactions, let's separate the left and the right halves of the arch like this. Since bending moment at a hinge is zero, we end up with only two unknown forces at each cut point. Further, due to symmetry, we have the identical forces at the right and left cuts. Now we can easily determine Ax using the left half of the arch. Summing the moments about the cut point, we get. We can determine Bmax in a similar manner. Now that we have all the support reactions, let's put the arch back together. Suppose we are asked to determine the internal forces in the arch, including axial force, shear force, and bending moment. To do so, we cut the arch at distance x from the origin. The free body diagram of the left segment of the arch looks like this. Note the horizontal and vertical distances from the origin to the cut point. We have labeled the horizontal distance x, so the vertical distance becomes f of x. This free body diagram involves three unknown forces, m, h, and r. We can determine m by writing the sum of the moments about the cut point. Here is the equation. Solving it for m gives. As the equation suggests, bending moment in the arch varies as a function of x in a nonlinear manner. Since some of the forces in the x direction must be zero, h must be 150 kilonewtons, and r must be 60 kilonewtons in order for the sum of the forces in the y direction to be zero. But note that h and r do not represent axial and shear forces in the member. Axial force must be in the tangential direction at x, and shear force must be in the radial direction, like this. If we refer to the angle that the tangent to the curve makes with the horizontal axis as theta, then we can express the tangent of the angle in terms of the derivative of f with respect to x. This means at a specific point on the arch, we can determine the tangent of the curve using this equation. Knowing the tangent of an angle, we can determine the angle itself. Then we can express n and v in terms of h, r, and angle theta like this. Since h is 150 and r is 60, our n and v equations can be written this way. So here are the equations for determining the internal forces in the arch. Let's use them to draw a diagram of each force. To draw the moment diagram, we need to graph this equation. This is for the left half of the arch, but since we have symmetry here, the diagram for the right half of the arch would be identical to that of the left half. This is a quadratic equation, so we end up with a curve like this. Note that bending moment at the hinge at either end of the segment is zero. We can verify this by evaluating the equation at 0 and 25. We can determine the point of maximum moment by setting dm dx to 0. Like this. The equation tells us that moment is maximum at x equals 12.5. Hence, the magnitude of maximum moment equals 375 kilonewton meters. Then, the diagram of the right segment looks like this. To draw the diagram for the axial force, we are going to graph this equation. Using trigonometric properties, we can write cosine theta in terms of tangent theta this way. And sine theta can be expressed this way. Then the algebraic expressions for the cosine and sine of theta become. Substituting these expressions in the equation for n, we get. The graph of this equation looks like this. The equation gives us 154.6 when x is 0 and 150 when x is 25. To determine the maximum value for axial force in the segment, we set dn dx to 0. That leads to this equation, which gives us x equals 12.5. Maximum axial force in the arch develops 12.5 meters from the left support. The magnitude of the force is 161.6 kilonewtons. Again, the force diagram for the right half of the arch is that of the left half. Finally, to draw the shear diagram, we are going to use this equation. Using the same trigonometric expressions as before, we end up with this equation for shear. The numerator for the equation tells us that shear is 0 when x is 12.5. To graph the equation, we need to evaluate it at x equals 0 and x equals 25. Here is the diagram. Shear is negative 46.85 kilonewtons at the left end of the segment and 60 kilonewtons at the right end of the segment. We mirror what we just drew for the left half of the arch and place it on the right half of the x-axis to complete the diagram. Here is the summary of the results. Moment diagram, thrust diagram, and shear diagram.
ओके गाइस, आई होप आपको सब अच्छे से समझ आया होगा। तो अगर कोई भी क्वेरीज है, कोई भी डाउट है, तो बेझिझक मुझसे पूछ सकते हैं। आप नीचे कमेंट भी कर सकते हैं। तो मेरी चैनल को लाइक करना और सब्सक्राइब करना ना भूलें। थैंक यू एंड गॉड ब्लेस यू ऑल।